the meaning of decision-making, the decision-making concepts, and the environments. We shall look at the EMV approach, decision trees, decision rules. So when we talk about decision-making, we are looking at that process of selecting from a set of alternative courses of action, the best option that you have, okay, which you believe is going to meet the objectives of the problem before you. So that process of selecting the best course of action is the decision-making process. And here we have several key terms, like the decision maker, who is the person charged with the responsibility of making the decision. Then we have the alternatives or the outcomes, which are events that are available to the decision maker and are within the control of the decision maker. So something that is within your own what? Your own control. Those are the alternatives. Then we have the states of nature, which are the circumstances that affect the outcome of the decision, but are way beyond your own control, like high demand, low demand, poor market, strong market. Those are states of nature. There's nothing you can do about them, but you find that they actually affect the decision-making process altogether. Then the outcomes is the payoff that you get from the decision that you make. We all know that each decision that we make has an outcome, or what we call a payoff. So the decision-making process is also examinable. You look at it. It is a 7-step process, starting with defining the problem at hand, gathering data about the problem, listing the alternative courses of action, identifying possible outcomes, estimating the profits or payoffs, then using a model, as we are going to do, to see how you can approach and solve the problem. So step number 7 is the decision-making point, where you select the best course of action. Then we move into the decision-making environments, which are basically 3. We have the environment of certainty. Now, under certainty, everything is okay. You know the outcomes, that if I take this course of action, or if I select this alternative, these are the payoffs, these are the outcomes. So you're very certain about it. Then the environment of risk is where you don't have 100% certainty, but you have some information and probabilities that can help you predict accurately the outcome. So we usually select the course of action using a model like the expected monetary value model, as you're going to see, which helps us in selecting the best course of action if we are facing the environment of risk. Then uncertainty is the worst environment you can ever be in, because here you don't know what's going to happen tomorrow. You don't know what's going to happen to you. So it even becomes very difficult to make a decision. Yeah, but we have different approaches that we are going to look at, which can be employed in the environment of uncertainty. So our discussion will begin with the environment of risk. And as I've mentioned, under this environment, we can either use the expected monetary value approach or the opportunity loss approach. So any of these methods we can use under the environment of risk. So under the expected monetary value approach, which is our number 1, should say, we select the alternative that gives us the highest expected monetary value, okay? EMV for expected monetary value. So we shall be calculating the expected monetary value for each alternative by multiplying the probability and the payoff. Probability and the payoff. So at the end of the day, whatever gives us the highest, which we shall call the expected monetary value maximum, is the one that we shall go with. So we shall run through this August 2017 quickly to see how that method works. Under this exam type question, we have a Kelo, a hotel proprietor in Ntinda, who would like to build either a small hotel or a large hotel. Her plans will depend on the future demand of the hotel will serve. She expects either hotel to succeed with a probability of a half. The profits expected from each type of hotel per annum in millions of shillings are shown in the table below. So in this table, they give us the two, these are now the alternatives, okay? These are now the alternatives. And then these are the payoffs that if you invest in a large hotel, you get 200 million if the demand is low, 270 million if the demand is high. If you invest in a small hotel, you get 160 million, demand low, 800 million, demand high. So using the expected monetary value approach, you can determine which alternative is the best, okay? So the low and high, we refer to these as the states of nature, and those are the ones that the payoffs are attached. So states of nature are things that are way beyond your own control. And then the alternatives are here. So to answer this, I don't know whether I should give you time to put down the question. Should I give you some minutes to put down the question? Or take a screenshot? Yeah? Should I give you some time? This is test of nature. And this is these are the alternatives. Okay, so members are saying we can continue. So to answer this, what we do, we calculate the expected monetary value for each of the alternatives. So beginning with a small hotel, which is marked as alternative 1, you can see that what I'm doing here, I'm getting the probability times the payoff for each state of nature. So 0.5 times 160 plus 0.5 times 800. So the result I get is 480. And then I check out alternative number 2, which is the large hotel, where I multiply 0.5 times 200 plus 0.5 times 270. So the 0.5 is the other half that was given. I'm saying that the state of nature can be turn out to be a half. It can be poor or strong. This is strong. Yeah, it can be low or high. So that is the half. The probability of the demand being low high is a half, which is the figure given here. That is the 0.5. So at the end of the day, I determine the highest EMV. The highest EMV, which is this one here under the small hotel. So meaning that this being the highest EMV, it becomes the best what? It becomes the best option. So let us put down this solution. You can look at it and see if it is making sense to you. Continue. Before investing in perfect information, you have to calculate the expected value of perfect information. So as I've mentioned, perfect information is that information that is of high quality and will help you to move from uncertainty to certainty, or from risk to certainty. Because with this information, you'll be making a decision based on research. based on that information. So as you know, research has a value, which here I'm going to simply say is the expected value of perfect information. That's why you have E of VPI. So EVOPI is expected value of perfect information. And we calculate that by getting the expected value with the W minus expected monetary value maximum. So the maximum is the other one we've calculated. And here I'm defining that EVWPI is the expected monetary value with perfect information. And EV max is the maximum expected monetary value. So what I need you to do is to write this formula in your books, and maybe you title that as expected value of perfect information. The rest of this text, you pick it from the slide. Since the slides are yours, you get the slides. Just pick the title, expected value of perfect information, which is calculated as EVOPI equal to EVWPI minus EMV max. And these are the parameters of the formula. So notify me when you're ready. We work out an example which will explain how this one works. Where I discuss the expected value of perfect information. So as you have written the other formula, there is a component of expected value with perfect information. So now I want you to put down this formula that we shall use to determine the expected value with perfect information. So the figure we get here, we substitute in our other formula to get the EVOPI. So let us put down this one here in next half of a minute. Okay, so we are going to go through June 2012, but before I do anything, I need from each one of you Roman 1, okay? Because I've already demonstrated how we get the expected monetary value. So in the first, before we calculate the expected value of perfect information, we determine the expected monetary value maximum. So what I need from you is to give me the expected monetary value for the two alternatives. One is settle out of court. Number two is go for trial. So let's do that. We continue. Yeah, good. So alternative one is to settle out of court. So settling out of court, you lose 8 million. Okay. I think the states of nature are winning and losing. Whether you win or lose, the lawyer wants the money, 8 million. So the probability of winning is 0.4, the probability of losing is 0.6. That's going to be negative 8 times 0.4, negative 8 times 0.6, which still comes to negative. You leave it as a negative because it is a loss. Then alternative 2, go for trial, as people have shown, is negative 7.6. Now, of course, you know that when you're comparing negatives, the best negative is the lower one. That's why I can see someone called admin. I think admin has, I don't know this admin. You don't put your name, but anyway, admin is saying that go for trial is the best option, which is true. Peace, I don't know what you've selected, but I see you are getting the same figures here. JB, you're not getting the right thing. Kemanti has the two right figures. Peace in it has negative 7.6 as the best, which is correct. Oh, admin is Mwajib. Good. Thank you so much. Kokasi, for you want to go with the highest negative. I don't know whether you can make it there. I don't think it's really good for you to go with the highest. So the best, the expected monetary value maximum leaves us with 7.6. So I'll give you just half of a minute for those who have not got it right to write this quickly. Then we go to the now the gist of the discussion, which is the expected value of perfect information. So now we have the EMV max. So what are we going to do now? We are going to calculate the expected monetary value of perfect information, which is going to be the expected monetary value with the perfect information minus the expected monetary value maximum, which we have got as 7.6. Now I want to take you to the other page where I'm calculating the expected monetary value with perfect information. So I'm going to work with, let me work with who? Let me work with Peace. Please unmute yourself. We work together, the expected monetary value with perfect information. Please unmute. Hello.
Yes, please.
Aha. We are going to calculate the expected monetary, okay, expected value, the M, they are leaving the M out. Expected value with perfect information. Do you still remember the formula?
With perfect information, best
We get
outcome.
Best
outcome.
Time with the probability.
Yes.
So let us start with winning. What is the best outcome out of winning between 8 and 1, -1?
Best outcome is 1.
-1. Okay. That's -1 times probability, which is 0.4.
Oh.
Then plus, now we go to losing. What is the best?
The best outcome is 8.
Is 8. So we get -8 times 0.6. So what are we doing? We are adding this plus that. So what do you get from your calculator there, Peace?
I get 34. Let's see. I get -5.2.
-5.2. And I think that's what every other person is getting. So thank you so much, Peace. So friends, I think you have seen what we have done with Peace. We selected the best outcome. Now, because they are negatives, the best will be the lower. You rather lose -1 than losing -8. You rather lose 8 million than lose 12 million. So, you know, there are cases where you feel like you're doing badly, but there's someone else who's doing worse than you. So this is the concept that a negative is a loss, yes, but negative, you cannot compare -1, a loss of 1 million, to a loss of 8 million. You cannot compare a loss of 8 million to a loss of 12 million. So this is how we get the expected monetary value with the perfect information. So now that you have seen that, we now substitute in our formula here. And now what is happening? This remains as a negative, but the negative outside the brackets affect the negative within the brackets, and that makes it a positive. So when I add the 5.2 and the 7.6, it straight away takes me to 2.4. So what are we saying? We are saying that the company should not pay more than 2.4 for perfect information. It's all about how much should be paid for perfect information. Okay? So the examiner is going to give you the cost of perfect information, like the cost of research. Because in most cases, if you're facing uncertainty, to deal with uncertainty, you do some research, understand your problem, and then you use that information to address the problem. So you cannot spend more than 2.4 on perfect information, because what perfect information brings to you is a maximum of 2.4. So let us do this in the next 1 minute. We continue.